Alright, for this problem, like all the others, we first recognize what type of exercise we're dealing with. And since we're trying to find forces, then this is a sum of forces equals MA exercise. So we're gonna need a body diagram. We'll have to draw the tension, which always pulls. Will be directed to the northwest. And we'll make an angle with the X, with the negative X. And the weight will be straight down. We know that the acceleration in the Y is 0 because the height is not changing, and we know that the acceleration is going to be towards the center of the circle, of the circular path, and the magnitude will be v squared over r. Alright, so first we do sum of forces in the Y that we know has to add up to 0. The Y component of the tension is T sine of 90 minus theta. The weight is straight down, so its Y component is just negative mg. Add these two and it should be equal to 0. Sine of 90 minus theta is the same as cosine theta, so the tension should be equal to mg over cosine of the angle. If you plug in the values they give you, then it should come up to be about 26.6 newtons. Then we do the sum of forces in the X. You know acceleration will not be equal to 0 in the X. Alright, so the X component of the tension here will be negative T times cosine of the 90 minus theta. And that should be equal to m times acceleration, which is negative v squared over r. Alright, so that simplifies to T sine theta is equal to mv squared over r. We know the tension is equal to mg over cosine of theta, so we substitute this expression into the previous one, and we get the mg over cosine theta times sine of theta equals mv squared over r. The m's cancel out, so when I solve for the speed, the sine over cosine will give me tangent to get a final expression of rg times tangent of theta, and take the square root of that. And you should get about 1 meters per second. Alright, I hope that's useful.